Lab number 3, natural frequency of spring mass system. Is everybody with me? All of you are able to locate this lab number 3, natural frequency of spring mass system.
Yes, sir.
Okay. So here first download this lab underscore 3 spring mass system. That is your write up. Just open the write up. Okay, so this is your write up. You can download and open the write up. Everybody is able to see the write up page.
Yes, sir.
Okay, so I will just read. The aim of the experiment is to study the longitudinal vibration of helical spring and to determine the natural frequency and time period of oscillation theoretically and actually by experiment. Okay, so this is description is given. Description is nothing but it is just simple spring mass system attached to a fixed support. All right. So we will directly go to the video. So you have to prepare this observation table: weight attached, spring stiffness, number of oscillation, and time period for that time period for oscillation. All right. So here first thing we need to calculate is the stiffness of the spring. All right. So to calculate the stiffness of the spring, what is the equation? It is W by del. Okay. So what we are going to do is open the video. Just go to your assignment and click on this link. It should open a video link. All right. So this is the basic apparatus. So I am just going to start with the video. So first thing I am going to show you in this video is how to calculate the spring stiffness. So all of you please note down the various readings that we are taking. Okay, we are doing this part of the calculations. Okay, we have first thing we need to calculate is the spring stiffness. Spring stiffness. So what we are going to do is, what is spring stiffness? Load per unit deflection. Okay, so here you have an unstretched spring initially. Okay, and to this unstretched spring I am going to give some load and measure the deflection. All right, so just note down all the values which are mentioned in the videos in your rough journal. Is everybody ready? Can I start? Gaurav?
Yes, sir.
Okay.
Today we will be doing our experiment. Uh,
Yeah, somebody was saying something, I think.
So where is the manual added into that?
Manual is in your assignment. See
Okay,
this lab underscore 3 spring mass system.
okay, so sorry.
Download that. All right, so all of you note down the initial length of the spring. All of you have note down the total weight which is mentioned in the video. All
Sir,
right.
your audio is not there in this video.
Sir, it was lagging a lot, sir. We couldn't see them.
See, you can open the video at your end also. I
Okay.
will switch on the audio. See, the link is there, no, in the description.
One kg plus you have to also add the weight of the bolt.
So initial length have you noted down, Gaurav?
Sir, it was seen like 7 centimeter.
7 centimeter. Final length is after you add the weight is 9 centimeters.
Okay.
Okay. So initial final length is noted. Now 1 kg mass is attached.
Excuse me, sir.
Yes.
Can you repeat what you said?
See initial length. See. Oh, just I'm just opening the. See here. You have to first calculate the change in length del. Okay. So you have to find out the difference between final length L after you add the mass and initial length Li. So initial length is 7. After you add the mass, the length is 9. Alright. So and the weight you are going to add is 1 kg plus 50 grams for the bolt.
That is 50 grams in each of the readings. Okay. So now after this is done, we are going to give the oscillations to this mass.
So this part of the calculation is now done. Alright. W is calculated, del is calculated. Now multiply W into G divided by del. So that will give you stiffness. Alright. Now here you have an observation table. Now here for all the three, you are going to take now three sets of three readings. Alright. For three different masses. But for all the three readings, K is going to be same because the spring is same. The stiffness of the spring is not going to change. Alright. So all of you in this in your rough journal make this observation table first before we proceed to take the reading. Any questions so far? Gaurav, everything is clear?
Yes, sir.
Okay. Now we will start with the actual readings. So now here I have, we are going to start with the 1 kg plus 50 grams for the bolt. So this will be our first reading. Since we have already attached the mass, we are going to take the readings for this mass itself. Alright. So now here when you are going to take the readings, see I am going to give some oscillations to this mass. You have to count the time for, so now keep your stopwatch ready, or you can use the time from the video also, video stream also. You have to measure the time between any 10 consecutive vibrations, oscillations. Is that clear? Alright. So the number of oscillations that might be shown in the video might be more than 10. But for your calculation, you can take any 10 consecutive oscillations and note down the 10 time for those consecutive 10 oscillations. Uh, any questions so far? Alright.
Sir,
So
what is the mass? 1 kg, right?
1 kg plus 50 grams for the bolt. Now you should keep a track of these things, sir. Now don't ask me again and again because that is a part of the experiment. You should observe the whatever is being said in the video.
Mass. So first reading is for 1 kg plus the mass of the bolt. So it gives so we are going to give some displacement to the mass, and you are going to record time required for 10 oscillations or 10 vibrations. Okay, so give some vibrations. Time no, no, time they will measure. सांभाळून नाही नाही तू स्टॉप नको करू ते लेट इट व्हायब्रेट हां सो अगेन विल रेकॉर्ड ओके 10च्या पेक्षा जास्त झाले ओके नाव स्टॉप इट all right so now you have to measure the time required for any 10 consecutive oscillations all right so that is your first reading.
All right, so you have to enter. So this is for 1 kg plus 50 grams. So 1 kg 50 grams. Stiffness is from these calculations. Number of oscillations is 10, and record the time taken for 10 oscillations. All right. So now we are going to take the second reading.
Now we are going to replace this 1 kg mass by 0.75 kg mass. पहिली बोल्ट So now the weight attached is 0.75 kg plus the mass of the bolt that is 50 gram. Okay, now again we are going to give some displacement to the mass and again measure the time for any 10 consecutive oscillations. Okay, so go ahead and give displacement. Okay, stop. Alright. So we have recorded more than 10 oscillations, but you have to record the time for so or you can record any n number of oscillations and divide that time by the number of oscillations you have measured. Right? Okay.
So what is being said in the video? You need time for one oscillation. Reciprocal of that time will give you the natural frequency. All right. So if you want, you can record 12 oscillations or you can record 8 oscillations. It doesn't matter. But in the end, what you should have is the time for one oscillation.
So this is the second reading. Now remove the mass and so we'll again repeat the experiment for 0.5 kgs. Okay, again give it some displacement. Okay, stop it. Alright, so that is how as far as the performance experiment is concerned, that's it. Now rest of the explanation I will give you during your practical session.
All right. So link has been provided to you in the description. If you go and open the assignment, see this link is provided: HTTPS, SVKM, SharePoint, etc., etc. So you can click the link and you can run it at your end. All right. So now let's go to the write up. So your recorded time for number of oscillations are 10. Your recorded time for 10 oscillations. Now calculate here. Add one more column, time for one oscillation. All right. Add one more column to the right, to this right, time for one oscillations. And now here you have to calculate T theoretical, that is twice pi into root of m by k. Here W is in kgs, not in newtons. Okay, m by k. So F theoretical will be 1 upon theoretical. So here you will get theoretical time, and here you will get theoretical T actual. Okay, that is T actual will be what? That is this one, T divided by n. Okay, so calculate the actual time for all three and theoretical time for all three. All right. So add columns for T theoretical. Sorry. Don't add the columns over here. See, there is another calculation table over here. All right. So T theoretical, T actual, F theoretical, F actual. Record all your calculations in this observation table. Don't add the. I am sorry. Don't add the columns over here. Add all your calculations in this table.
Sir, in the second table, we have to add time for one oscillation or 10 oscillations in the
The
like
calculation table.
second.
Calculation
Yeah,
table.
the
One
actual this thing.
one oscillation.
Thank you.
One. Here it is everything because one divided by t is your natural frequency in hertz. All right. So here you have to calculate theoretical. Here you have to calculate actual. Record all the values in this observation table. Okay. Any questions so far? All right. Here all the details are given about the notations used. Here draw the diagram of a simple spring mass system. Draw the diagram of the free body diagram of the spring mass system. No need to like draw the whole setup. Just draw the representative diagram. Okay. So that is it. Now after that, so this is as far as experiment is concerned. Okay. Now after that, see, I have asked you to do some additional things. These things you are not going to do it now. Okay. These things you can do it at home later. All right, because see, other batch has already completed 6 experiments. Okay, all right, and your batch has completed only 4 experiments. So you are lagging by 2 experiments. And again, next week you have your term test. So again, you will be losing one more turn of your practical. So we are going to do 2 experiments today. All right. The remaining things about for the experiment, that is creating mathematical module for the experiment, derive governing differential equation using D'Alembert's principle and energy method, solve the governing differential, generate sample data in Excel to plot a graph of displacement versus time. Okay, just like you have done in the experiment, sorry, in the assignment, you have done this. And those who don't have access to Excel can do the graph manually in graph paper. Okay, after that, you interpret the results. Okay, and this work, all these things from point 1 to 6 till interpretation of the results, all these things are to be attached as a supplement to this write-up. So once this write-up is done, this calculation is done, and draw the diagram. After that, attach all these things, all these things up to point 6. But now I want you to do only this part, that is just complete this table and tell me what do you observe. Okay, so only that part is to be done. I will be giving you say maybe 15 minutes. 15 minutes I will give you. After that we'll start with the MATLAB part. Any questions?
So we have to take the printout of this material, write up.
Yes, yes, you can take the printout of the material and then fill it. That will be your final thing, but for now you just do it in rough.
Yes,
Just
yes.
huh. Now you do all your work in your rough journal. Keep a note of that. Okay, no need to upload anything right now. Just complete this observation table and tell me what do you infer from that. Okay, so the everything that
Sir,
has to be, yes,
sir, the 50-gram bolt is there for every reading, right?
every reading,
Or
correct, because that is the bolt is there for all the 3 readings, right? So whatever mass is added, say 75 750 grams, so you have to add the 50 grams to it.
okay.
Any other questions? All right, so I will give you 15 minutes. Everybody has access to video. Everybody is able to play the video at your end. Gaurav.
Yes, sir.
Yes, sir.
All right, so time is 2:35. So I will give you 15 minutes. That is till 2:50 to complete the experiment. And after that, the remaining part of the just do the calculation. Remaining part of the experiment you can complete it at home. After that, we are going to start the Simulink. Now, those who have MATLAB with you, see, the MATLAB might take a time to load. So go ahead and open your MATLAB and keep it ready for the next part, next experiment. How many of you have MATLAB installed on your PC? Please raise your hand in the in your chat box. Okay. So open up the MATLAB. After you open the MATLAB, you have to go to you have to open the Simulink. See on the home window, everybody is able to see my MATLAB window. Hello, Gaurav.
Yes, sir.
Huh? So go to home tab. All right. On the home tab, there is this button for Simulink. Okay. Click on the Simulink. Once you click on the Simulink, you will get this for option called blank model, and click on the blank model. All right. So after you are done with the calculation, simultaneously also do this thing, because if you are running these things for the first time, it takes a bit of a while. All right. So keep all these things ready. Any questions? All right. So I will give you 15 minutes to complete your calculations. After that, we are going to start with the Simulink.
Sir, how much of hello, sir?
Yes, how much error are you getting? Yes, somebody was asking me how much error is allowed.
Yes, sir.
How much error are you getting?
About 0.05.
0.05, na? The 0.05 in what? In what?
Second between theoretical
In
and
time.
actual time.
Theoretical and actual time.
Yeah, yeah.
That is okay. 0.05 second is absolutely fine.
Sir, there is a lot of disturbance.
Huh? Yes?
Disturbance, sir.
Disturbance.
Sir, we upload it once we are done.
Hello, is everybody able to see this? Gaurav?
Hello, yes, sir. Hello.
Hello. Hello, Gaurav.
Yes, sir.
Somebody was asking me whether to upload the write-up. So don't upload the write-up. First, complete the write-up. Take a printout of that, complete the write-up. And then after that, you have to do all these things from 1 to 6. Are you able to see the screen?
Yes, sir.
Tab number 3, natural frequency of spring mass system. So you have to do the complete the write up, take a printout of the write up, fill everything till the diagram, scan those pages, then complete from 1 to 6. After you complete from 1 to 6, you have to com- compile everything in a one single report and then submit it for final correction. I don't want partial report today. Today I'm not asking anybody to do any partial report submission. Any questions? Gaurav, is everything clear?
Yes, sir.
Okay. All right. So is everybody done with the calculation? Can we start with the MATLAB Simulink part? Those students who are going to do the Simulink, have the Simulink ready on your PC, please raise your hand in the chat box, so that I get a good feel of how many students are who will be doing the experiment with me. Okay, those students who have installed the MATLAB, uh, just run the MATLAB, open the MATLAB icon and open this Simulink window.
Sir,
Yes,
sir, we have to upload a lab 3 before TT2 or after TT2?
you can upload it after TT2.
Okay, sir. Thank you.
This work, this week, whatever work I'm giving, you can upload it after TT2. Whatever work was given before this week, and whatever work is being done during the lecture, that has to be up to date. That is the balancing problems and all that. All those things should be that you have to do it before the exam. Alright. So whatever is being because for balancing the assignments are being done in the lecture itself. So students are uploading it during during the lecture itself. So that has to be done before the term test. Okay. As far as the experiments which will be conducted this week, that you can do it after the term test. Alright. Just alright. All of you keep your MATLAB ready and see. All of you are able to see the screen. Gaurav.
Yes, sir.
Okay, so in this you have this lab number 7. Okay, study force vibration using MATLAB Simulink. So click on that. And go to this. There is a write up. Just download this write up and go through this write up. And so our MATLAB Simulink experiment will be based on this. So open this. Keep your Simulink also ready. So I will give you 5 minutes to go through this, and then we can start with the experiment. Okay, I will be back in 5 minutes.
Hello, is everybody ready? Gaurav?
Sir, there is a lot of background noise.
How about now?
Now it's fine.
Okay. Is everybody able to see the Simulink window?
Yes, sir.
Okay. All right. So in that window, there is this icon says library browser. All right. Click on that. All right. So this should open up this window. So basically, this software is a drag and drop type of software. Okay. So we are going to start. Let me open up the Word document. So we are going to study the force vibration using MATLAB Simulink. We have already studied it using scripting. Okay, using code. So we have in our theory class we have developed this governing differential equation for this spring mass damper system, right? And this was our governing differential equation: x double dot is equal to 1 upon m into f minus k by kx minus b into x dot. Here b is nothing but your damping coefficient. Instead of using c, we are using b. All right. So this is the block, the flow chart or the block diagram. Okay. So here force is the input. Okay. And you have your force. So you have to arrange your blocks according to this. All right. So acceleration is coming here. Then it is there is a integrator block over here that integrates acceleration into velocity. So velocity into damping, that is b into x, that is vx dot. Then again this is going further. Another integral block is placed, that is integration of velocity is displacement. And here you have k into x, so x into stiffness k, and both these terms are getting added. All right. And they are added to this f into 1 upon m. All right. And these two things, bx dot plus kx, they are subtracted from f by m. Okay, and whole thing is scaled by f by m. All right. So f plus f minus bx dot minus kx into 1 upon m. This is whatever coming out of it is your x double dot. All right. So that is how you have to arrange your block diagram. All right. So keep your block diagram handy at all time. And so one by one, we are going to start with uh, the plot. Okay. So any questions so far? All of you have opened the browser, Simulink library browser. Varshil, are you doing the? Do you have the MATLAB with you? Not Varshil, apna Gaurav.
Sir, I have online MATLAB, so I am not able to access that.
Okay. I need somebody to, you know, Sharva Poddar. Who is Shubh Shetty? Those who have MATLAB installed
Yes,
and
sir.
ready, please raise your hand in the chat box. Okay, Durvesh Devkar, have you opened up the browser?
Yes, sir.
Okay, all right. Okay, so now we'll start one by one. So first go to sources. Right.
Hello, sir.
Yes, just a minute. Huh?
Sir, Acha, you have not started, na?
No, no. All right. So first go to this continuous window. All of you are able to locate this continuous window. In this, you have this integrator. All right. So pick two blocks of integrator. One more. All right. And join this. Right.
So can you repeat how did you do it?
Just see, go to this browser. Okay. In this browser, see there are various options under this. In that, go to continuous. Okay. In continuous, you will find this. There is this integrator. Are you able to see the screen? Right? Are you able to see the screen?
Yes, yes, yes.
Okay. So here, go select this integrator. So you have to just drag and drop it in this window. Okay. Another select another integrator, drag and drop in this window, and then just connect this. Just align this little bit like that. Okay. Done with this. All of you are able to do this. Can I go to the next step? Durvesh.
Yes, sir.
Okay. Now go to this math operations and click on this gain, and again do a drag and drop in this. All right. Then right click on this and select this rotate flip and just do a flip on the block and join it with the integrator.
So can you explain again?
Just a minute. See, go to this window. Just delete this. Go to the browser window. Go to math operations. Select this gain block. Drag and drop it over here. Okay. Then do a right click on it. Go to rotate flip and flip the block so that the direction is flipped, and just join it to this block. Done. Durvesh, done.
Yes, sir.
Okay, now go to this same browser window, add one more gain, and then again repeat the same step. Do a rotate flip and flip it horizontally, and join it in between the two integrators. Okay, then double click on the blocks, and from that one change it to K for stiffness, and click up OK, and then click on the second one and type in B for the stiffness coefficient of damping coefficient. Okay, here instead of C we are using a slightly different notation, that is B.
Sir,
Yes,
sir, can you please zoom in?
just a minute. I just How about now?
Yes, sir.
Okay. You are not
Sir,
able to access Simulink in the web version.
No, sir.
Okay.
sir, when we rename it B and K, it is giving some sort of. Can you show how to do it again?
See, just double click on it. See, by default it will be written 1. So
Yes.
delete that 1 and replace it with K and click OK. Similarly, this one also replace that 1 and replace it with B and click OK. So what we are doing here is, see, we are going to input these parameters as variables from our MATLAB prompt. Okay, here we have your MATLAB prompt. So here we are going to input what is B, what is K, what is M, like that. Okay, so we are going to we are making those as variables.
Showing us unrecognized functions or variables.
Pardon?
It's showing us unrecognized variable.
That is okay because we have not defined it, na?
Okay.
Huh. All right, Durvesh, done.
Yes, sir.
Okay, now in math operations there is this one more block called as sum. So pick it up and drag and drop. Do it. Just move it over here, and again do a right click and do a rotate flip. Okay, and connect it here. All right, done, Durvesh.
Yes, sir.
All right, now add one more sum block over here. All right, and then in the browser window, go to sources. All right, and in that, go to step function. Right, and just join this, join here, and click on this one and make this minus. Okay. So I'm doing it according to the block diagram. Done, Durvesh.
Yes, sir.
All right. Now go to what do you say, the math operations, and add one more gain. All right, and double click on this block and change it from 1 to 1 by capital M, and click OK.
Sir,
Yes,
what is the name of that circle? Sum?
this one, sum.
Okay.
You don't have to write the name, it is already there by default. All right, done everybody. Can I proceed to the next step?
Yes, sir.
Okay. Now go to sinks. So now whatever output I am getting, I want to see it on a scope. So I am going to select, go to sync and select this scope and place it over here and connect this to. Now there are two inputs. Now I want to convert two inputs to one input. So go to signal routing and select this bus create. Alright, so what does this bus creator do? It merges two signals together.
Sir, repeat, sir.
See, go to this browser, go to signal routing and select this bus creator and drag and drop it here. Okay. So what is this bus routing? It converts two signals into one output in this scope. So we'll join this one over here and the second one will drag it all the way here and connect this to together. All right. So I think we are all done. Now we'll define the variable. All right. Now go to your MATLAB window and define. I'm going to do a clear all. All right. Now I'm going to define the variables. Capital M is equal to 10, B 2, and K is equal to 5. So I've defined these variables. Now go to the Simulink window. just run this simulation. And just click on the scope, and this will give you the output. All right. So you can see the input is the step input, and this is the output. That is the sinusoidal, and it is decreasing. Everybody is able to get this.
So we put in the values, but it still shows that red coloration around K and D for the error.
How many of you are able to run it? Durvesh?
Yes, sir, it's running, but the problem is there, like the server told.
What is the problem?
It's showing undefined variable, but we got the
So,
output. Means I got that.
but you are getting this output, na?
Yes,
You
sir.
have defined the variables now in the MATLAB window.
So, can you repeat from after you've made the model?
After making the model,
Yes, sir.
model is done. Just minimize the. Now go go to the MATLAB prompt. Okay, I'm just going to do the same step again. Just going to clear. See here the variables are seen over here, right? So I'm going to clear everything now. Clear all. All right. So all everything is blank now. Now define mass is equal to 10. Enter. All right. Coefficient of damping coefficient is equal to 2. Enter. And stiffness is equal to 5. Enter. All right. So now variables are defined. Now we are going to go to the Simulink window. Now make sure you close this window and just click on run. All right. After you hear the sound, click on the scope. And you should see the output. All right. Now what we are going to do? We are going to uh, plot the output by sending this output to the workspace. Okay, so I'm just going to close this and again go to the browser window and go to thing. Select this to the workspace, that is sim out, and drag and drop over here. Right. So now the output will go to this variable out.simout. All right. So just select over here and join it over here. Right. Right. Run the simulation and go to the MATLAB run. Same plot out dot same out. All right. So this will give you a proper graph. This is your input. This is your output. All of you are able to get this graphical window?
So can you repeat once?
Go to the browser window and select the go to sinks, select this sim out and drag and drop in this workspace. So sim out and drag and drop in this workspace. Okay, and then join it with this here. Give an additional branch. Okay, then run the simulation. After you run the simulation, go to the MATLAB prompt and type in simplot out.simout. Don't type anything out like after that, and that will give you this output window. So I'll just do it again. Simplot out.simout. Type it enter, and this window appears. So this is your step function. That is the input. All right, and the spring mass damper system, as you have seen the calculation, it is a sinusoidal and it is decreasing, exponentially decreasing. All right, so that behavior is C. Durvesh, are you able to get the output?
Yes, sir.
Okay. Now here, you see the time is very less, so I am not able to get the proper characteristic. So I am just going to close this graphical window and I am going to increase the time from 10 to 100. Okay, and I'm going to run the simulation again and just go to the MATLAB window and again do the simplot, and now you can see this proper behavior of the system. That is, it is varying sinusoidally and also it is amplitude goes on decrease. Are you able to get it? Those who are doing it with me.
Sir, can you tell the sim code again? Sim out code.
Sim out part.
Yes, sir.
Sim out part. See, go to the. This is your window, right? So open the blocks browser. Go to sinks. These are various options, right? Go to sinks. In the sinks, there is this option
No, sir,
called as
not this one. The code that we had to add.
what code?
Sir, you added now in the code in the command window.
See the stop time in this window. You see this stop time.
Yes, sir.
So first, did you change the stop time?
Yes, sir.
Change it to 100.
Okay.
After change it to 100, just run the simulation. I'll just close the window just a minute. Close the window. Otherwise, after you change it to 100, run the simulation. Go to after you run the simulation, then go to the MATLAB prompt and type this command simplot out.simout.
What?
Out
Out.
dot. See, I have typed it on the screen
Yes, sir.
and just press enter. So this window will open. So here you can see the step input and the output, which is this is what type of vibration. As you can see, this is the under damped vibration vibrating system.
Yes, sir.
Okay, so this is an underdamped vibrating system. Right. Let me just close the window and let me just try something to do the clear all. Okay. So flush the variable and I'm just going to try something. D is equal to 10, A is equal to 5, M is equal to 5. And then I'm going to go to this window, run the simulation again with those variables. And then again go to the MATLAB prompt and do out dot simplot dot out dot sim out. Oh, now what do I get over here? Can anybody interpret this result?
Sir, overdamped system.
How do you know it is overdamped? Just calculate the zeta for this and see what type of system is it. You have the damping coefficient and you have K and M. Just calculate the zeta value and see what is the damping ratio for this. Yes, anybody calculating? Gaurav,
Sir, can you show the mark? Yes.
as it's on the screen.
It is critically damped. Zeta is
Critically
coming as
damped,
1.
right? Zeta is coming as
1, 1.
1.
1, right? So it is a critically damped system, not a over damped system. It is a critically damped system. So as you can see, the output goes to 0 and then it just remains constant. There is no, what do you say, the oscillation is seen only on one side. It is not crossing the x-axis. As it is seen, there is no sinusoidal effect in this system. All right. So in this way, you
Sir,
can
in this y-axis represents what thing? Means on y-axis 0.2 is
y-axis
shown.
is
So
the
what is?
displacement. Y-axis is the displacement.
So it will not come to its initial position after rest. It will be deflected by 0.2 mm.
No, no, no. See, it is this is all relative. Okay, this whole scale is relative. All right. So you are not set the scale. All right. So it is 0 to it is calculating on its own. So it is coming to the mean position. It is going to some position and then it is dying out like that. It is. Don't pay attention to the scale. It is not set properly. Like that you have to do this. This part you have to do it. Okay, now let's go back to the variables we had earlier. So clear this thing. What is variable we used earlier? is equal to K is equal to dot run the simulation again. Run the simulation again. Plot. All right. So this is for the under damped system. Okay. Now one more thing. Any questions? Please ask.
Sir, can you go to the model, that Simulink model?
Can we?
Simulink model. Can you show the Simulink model?
Just yeah.
Sir, in this we cannot directly attach these two output to the scope, so we will get direct result in scope instead of using that strip like thing.
Which one? The out dot
Uh,
sim out.
no, the above one. This bus bar or something as there. No.
No,
Uh,
there are two signals, na. See, if you want to connect only one signal to the scope, then you can connect directly. But I have
Sir,
to
we
take
can give signals to the scope, right? Because
no,
it will
not
show means
directly.
to her.
See, I have to take this input, that is the step input, and I have to take the output, and I want to plot them simultaneously, right? So both these things you cannot just connect because there is only one input to the scope. See, if you
Sir, if
just
we
go,
drag the arrow directly, it will show two inputs, right?
just
Means
try it and see if you are able to do it. You have the Simulink window open, right? Just try it and do it.
sir, actually, I don't have it right now, but before I have tried, so it was uh, working that way. That's why.
I'm not sure it is going to work. Okay, fine.
Sir, can you try it once on your screen?
No, it will not work on this screen. It doesn't work like that. For this version, it doesn't work. I don't know. Now, suppose I need. Now here I have the input and displacement. Instead of that, I also want velocity. All right. So I just double click on this bus bar and number of inputs instead of two, I change it to three. Okay? And I take it from here and join it somewhere over here. Everybody is doing this along with me.
Sir, can you repeat?
See, double click on this block and number of inputs change from 2 to 3. All right, and click OK. And then just take this one output and join it with this over here. Let us add. after the first integrator. Correct. After that, run the simulation. And just go to the MATLAB window and just do simplot. All right. So now you can see the input, the displacement, and the velocity. All right. Okay. Now, when you prepare the report, see this is you have to attach these two pages for theory. All right. After that, take a just save this as a figure or take a screenshot. See, you can take a snapshot of this. All right. So it saves the snapshot. It is saving. I don't know. Maybe it's saving somewhere in the workspace. Or take a snapshot of it and attach it in this below this. All right. So write the title Simulink block diagram for the spring mass damper system with force vibration. So add this diagram, put a proper title to it. All right. And then also uh, get this graph, these graphs, that is input, uh, then this displacement and velocity. All right. So now I have done it for step. You can try some other inputs, some other sources like sinusoidal, and you can plot this graph. You can just play around with it. Okay, save your work.
Sir, we have to add both the diagrams, like the output and the circuit diagram, both in the Word document.
Yes. All right. And so you that should be your report. So start compiling that and upload it on the start compiling the report, add the block diagram, add those graphs through proper title, and then just compile the whole report and just submit it on the what you say the your team's portal under the assignment. That is experiment number 7, force vibration. Lab number 7, study force vibration using MATLAB Simulink. All right, complete that. I will give you 15-20 minutes for that. In the meantime, if you have any questions, please go ahead and ask.
Sir, we have to upload a model diagram and
See, just modify this Word document, add the block diagram and these three graphs. That is the step input and this output. And also, what I want you to do, instead of using this step input, this browser window, sources, we have used this step, right? So use the sinusoidal one or try some other input. All right, there are these various input. pulse generator or ramp input, repeating the sawtooth. All right. So at least try or the sine wave, okay, sinusoidal, and see how are the outputs you are getting, what output you get, and plot and add this. Then add that whatever modification you make to this block diagram. Take a screenshot of that block diagram also, and also add the three outputs from this window. Did you understand the second part, the last part? Right, if you have any questions, please ask. So after you have uploaded this complete report, I will take the attendance. Any questions?
Sir, everybody has to upload it right now, no? For
Yes, yes,
Simulink.
yes. Okay, how many of you were able to successfully complete today's task? Please raise your hand. Those who are doing it using MATLAB. Only 7 students. Okay, this all the 7 students. Can you at least upload the only one of this graph which I have just shown? The don't I don't want the second part. Just take a snapshot of this graph and just can you upload it in your what do you say? How many students are there? 7 students are there, no? 2, 3, 6. I can see only 6 now. 7. Are those 7 students who have raised their hand? 8. All right. The 8 students who have raised their hand, I would like them to take a screenshot of this.
Sir, we have to upload in the chat box or
No, no, in the assignment,
okay.
in the response on the assignment. Now, before uploading, what I want you to do is, I will just call out the name. Go to the what you say the source window. So here you have done it for step, right? All right. So I have just call out the names. So accordingly, you change that step function to whatever I am saying. Okay. So first student Trisha Rane, change it to sine wave and run the simulation and upload the output. All right. Then
Yes, sir.
hello. Durvesh Devkar, attach this, replace the step with this repeating sequence.
Okay, sir.
Right? Shobit Maniar, and then run the simulation and attach the output graphs. Shobit Maniar,
Yes, sir.
replace it with ramp signal.
Okay.
Sanchit Gujran, replace it with pulse generator. Shubh Shetty, replace it with random number. Vaishnavi Nambiar, replace it with waveform generator. Sanjit Ramteke, replace it with random number.
Yes, sir.
Charva Podar, replace it with repeating sequence. Everybody is familiar with the task. So I want these 8 students to immediately upload that this window. Take a screenshot of it and upload this window. Once you are done, please let me know. Durvesh Devkar done.
For 2 minutes.
I don't want the entire report. I just want that one window. Huh? For now, I want the one window. Later, you can do the entire report. Right now, I just want the one window.
Done, sir.
Done. Trisha Rane done. Just a minute. Just let me refresh.
So I have also done.
Durvesh Devkar done. All right. Good. Good. Very good. Trisha Rane. Trisha Rane is also done, right?
Sir, please check Shubshet.
Yes,
Just a
sir.
minute.
Sir, even I'm.
Just a minute. One by one. Okay. Trisha Rane is done. Who else?
Sir, I'm also done.
Who
Server.
is Charva Poddar?
Sir, I'm also done.
Who is that? Shubh Shetty.
Sir, Shubshetty.
No, no, no. I want a graph. Graph. Don't. I don't want a Simulink. This file. Shubh Shetty. I want a graph. Graph.
Sir, can you check mine?
Charva Poddar. All right. Good. Okay. See, whatever is the graph output for velocity, you can observe. If are you able to see the outputs which I am sharing on the screen? Everybody.
Yes, sir.
The displacement is the sinusoidal with decreasing amplitude. All right, and some of them have this additional signal built into it. Okay, but majorly the signal is sinusoidal plus this exponentially decaying feature. Sharo Podar is done. Who else is remaining?
Sir, I have also done.
Who is that?
Sanchit Gujarat.
Sanchit. All right. Okay. Okay.
Sir, even I have uploaded Shobhit Namya.
So bit much. This is for the step input, huh? Ramp input. Is it?
Yes, sir, Ram.
Who else is remaining? Ranjit Ramteke is remaining. Vaishnavi Rambiar is remaining.
Yes, sir, uploading.
So I'm also uploading.
Okay. What about the rest of the students? From the 8 students, those who are for those who I have already checked the experiment, you can lower your hand now. Only Sanjit Ramteke and Vaishnavi Nambiar. Shubh Shetty is also remaining. Yes. What about the rest of the students? Now, other than these 8 students, how many of you have access to MATLAB and still are were not able to?
Sir, please check Shobh Shetty. I have uploaded it.
Why are you getting this flat line? Something wrong with this. You should not get a flat line.
Sir, others have to upload the screenshot of the model and graph, right?
No, no. So, what are you going to do for this? Like, how many of you have access to MATLAB other than these 8 students who have access to MATLAB were not able to do it today? Like, how many of you are planning to do it? Okay, Vaishnavi, the 3 students, Vaishnavi Nambiar, Sanjit Ramteke, all of you, lower your hands. Once you are done uploading, just let me know. Sanjit Ramteke, lower your hand. So only 3 students, Sup Padecha, Prasanna Pujari, and Shruti Jadhav. 3 students have raised their hand. All right. So will you be able
I'm
to?
also getting a line actually.
Who is that?
Vaishnavi,
For which type of input?
waveform generator.
Okay, okay. Now, so what you do instead of that wave, no, who was the other student I just talked to?
Shubh Shetty.
Shubh Shetty. You also using, what is the input you are using?
Random something. Random numbers.
Okay, now both of you uh, use this
Sir,
sine wave.
upload this one.
See, if you are getting a flat line, uh, just try using the sine. Instead of that, replace it with sine wave inverter. Sine wave, replace the input by sine wave, and then plot the graph and upload it. All right. So, are you going? So these five students: Shubh Padecha, Prasanna Pujari, Shruti Jadhav, Smith Angara, Gaurav Kakra. So, will you be able to do this experiment?
Yes, sir.
Okay. So, I'm just taking a screenshot. Five.
Yes, sir.
So, Shubh Padecha, Prasanna Pujari, Shruti Jadhav, Smith Angara, and Gaurav Kakra. Okay. So, just note down the inputs that you are going to use. So, one part will be the step input that I have given you. All right. Shubh Padecha, sine wave, Prasanna Pujari, pulse generator, Shruti Jadhav, ramp, Smith Angara, repeating sequence, and Gaurav Kakra again sine wave. All right. So, you have to change that step input to this, whatever I have given you, and again just so you have to plot these two specific. Okay. All right. What about the remaining students?
Sir, uploaded now.
Okay. Yes. What about, so remaining students? All right. So since you are not able to, you don't have access to MATLAB. So what you are going to do is, instead of a spring mass damper system, all right. So here we have created this document for a spring mass damper system. Okay. So what you are required to do is repeat the same steps, and you have to imagine the system with force vibration with no damping. All right. So replace this diagram, create this uh, draw a diagram over here, then write the equation. Okay. Then modify this block diagram as per the, as per this system, that is spring and mass system. So in that case there will be no damping. So take B as 0. So you have to modify this diagram. All right. Then create a block diagram in Simulink, but now you are not going to create it using this this software. Just you have to create it manually. Is that clear to all the students? All right. So that has to be done for those students who don't have access to MATLAB. They can do this exercise manually, and also plot the graphs. Now you can plot the graphs when f is constant. When sorry, when f is equal to a sinusoidal force, that is f is equal to f0 sine omega t, like what you have done in your theory, and accordingly plot the, so plot the input, displacement, and velocity. These graphs you have to plot. You can either use Excel, or you can do it using manual graphs.
Excuse me, sir.
Yes.
Sir, you gave us each like a sequence to use five people. So we have to take a snip of only that or sine wave as well.
So who is talking now?
Smith.
Smith Angara.
Yes, sir.
I have given you this. So in
You've given
addition,
me repeating sequence.
repeating sequence. So in addition, just see, one is the step which I have showed in the lab. Okay.
Okay.
In addition to that, you have to do the repeating sequence.
So in
The
the write up,
report
I
you
have
have
to
to,
attach both, right?
so you have to replace this by repeating sequence. Take a snapshot of this block diagram and also attach the snapshot of the output.
Okay. Thank you.
Sir, I have Shubh Shetty,
Thank you, sir.
sir, I have done sine wave one.
Just a minute. Let me just save this. Let me just take down the attendance first.
Thank you, sir.
All right, those who are done can leave. Only those students who have any questions can wait. All right. So who was that? Shubh Padecha, na? No, Shubh Shetty, na?
Shubh Shetty.
Sir Sanjeet also. Can you check?
Vaishnavi Nambiar was also there, na? Okay, Vaishnavi Nambiar. Then who is that? Shubh Shetty, na?
Sir,
Yes.
sir, actually, I will try today just downloading MATLAB because I was trying online and it is very lagging. So I have done it, but it is incomplete. So I can choose any one of the input and upload it by today tonight.
Who
It
is
is
that?
fine.
Just a minute. Wait a minute.
On a,
Sir, I turned in.
Who is that?
Sanjeet.
Ram Tech. Okay, I am seeing only two signals, but I want three.
Sir
This is
Shetty Shubh done, na?
Sir, I'll check
Shubh
again.
Shetty. Shubh Shetty. Wait. Where is Shubh Shetty? Okay, now again there is this flat line. No? Oh, there is no output after this. Why is it like that? This looks something is not correct here. All right, you try it again, Shubh Shetty. Just check your. All right, so we are going to stop right now. Shubh Shetty and Sandeep Ramdeke,
Sir,
you can yes,
Yes, sir.
you can try
sir,
it and again upload it. Yes, go ahead.
sir, I have downloaded the MATLAB,
Who
but
is that?
so Shantanu Thorat.
Huh.
So, but in that the Simulink wasn't included. So, and that I came to know before the lecture. So I couldn't do that. So I'll download the Simulink and then afterwards I'll submit that. So is it okay?
Who is that? So for you, you have to Shantanu Thorat.
Yes, sir.
Yes, the same issue with Ronak. Means I was also asking the same. By tonight I can do it.
Who is that?
Ronak sir.
Or Shruti Jadhav, Smith Angara. So Ronak Gohil and Shantanu Thorat. So you are planning to do it today, is it?
Yes sir,
Yes.
but
Yes, sir.
not right now, but later on.
Yes, sir. Yes,
Okay.
sir.
Okay.
Yes, sir. Same.
Let me just add your name to the list. Shantanu Thorat and Ronak Gohil, na?
Yes,
Yes,
sir.
yes.
Okay, I have added your names to the list.
And sir, for the input, we can choose random or you are giving it.
For I will tell you which input you have to choose. Shantanu Thorat, you choose the ramp input,
Okay. Okay.
and for who is the second student?
Ronak.
Ronak, you choose the repeating sequence.
Hello.
Hello.
So even I
Okay,
am
sir.
doing RAM.
No, that is fine. Who is
Okay,
that?
okay. Shruti Jadhav.
That is fine. All right. So we'll stop for today. This session is already extended too much.
Okay, sir.
So if there is no more questions, we'll end the session.
So by when can we submit?
Which one?
So
Sir,
these two
Shubh
stuff.
Shetty has
Today, by today, you have to submit. Those are
Okay, sir.
those are promised to do it using MATLAB.
Yes, sir.
Yes. Somebody was saying something. Who was that?
sir. I have done again, sir. Shubh
Which?
Shetty. Shubh Shetty.
Hold on.
Sir, same sir. I tried. Sanjeev.
Sir,
Yes.
I have also done it again.
Who is that?
Sir, I uploaded the whole experiment with that
Who is that?
whole PDF file.
What is the
Sanchit
name?
Gujarat, sir.
Sanchit Gujar. Okay. This
Sanchit
is
Gujarat.
okay. Sanjit Ramteke, this is okay.
Yes, sir. Thank you.
All right. And then who is that second student?
Shubh
Shubh Shetty.
Shetty.
Sanchit Gujarat.
Okay, this is also fine. Remove that earlier one. Simsings.png. That file you remove. Shubh Shetty.
Okay, sir.
All right, we'll stop for today. I will. Those who have submitted the complete report, I will check it later.
Thank you, sir.